Okay, so K-means clustering, which is nothing but basically grouping the data into a set of the groups based on some kind of similarities. And but just to kind of like start off as a basic stuff, which is basically it is a family as a part of the machine learning family, right? So the machine learning is there's two main things. There's another one called enforcement learning or something, but we don't talk about that. Like, let's focus on like just supervised learning, unsupervised learning. These are the two main things in the machine learning world. And then that thing we're going to talk about, we're going to take a look at is unsupervised learning. What is unsupervised learning is to basically the second point is the most important thing here is that like you don't have answers in your data. It's not like this customer becomes a loyal customer or not. That type of answer, we don't have it. However, we want algorithms to find useful patterns and trend in the data. Therefore, that can provide us some useful insights, hoping that will help us, make better decisions. And to do the for the unsupervised learning, though, there are not just clustering. There are other type of methodologies as well. And one of them happened to be the clustering. The inside the clustering, before going to the inside clustering. So again, just make sure, I want to make sure that what the clustering is. It's just you have the bunch of type of people, for example, and then you want to separate. And then when you separate, basically what you're looking at is like what are the similar things among the people within each group, right? So let's say like you have the attributes, right, for the person. And then in this case, for example, like she is a woman and then generation X and an actor, the job is an actor and she's making a lot of money and she's American and so on. Those are the attributes. We call it also like variables or features, predictors. Basically in this context, those are the same thing. And then like you got a bunch of people, right? And then like when you have this, hey, you know what, like I want to actually group into a set of the groups based on the attributes that I have. And then maybe like it can be in the two groups of the politicians and actors. But this probably like you can get like one variable called job, and then like you can just group into the two. So that's not really like, we don't even need an algorithm to do that. However, like you might, like if you have lots of attributes, you might find the algorithm might find some of the patterns that we couldn't just by using the one or two variables. So for example, in this case, what are these two groups? And then here's the thing though, is that like the algorithm is not going to tell us like what exactly this group is. That's our job to say like, hey, you know what, left-hand side of people, you know what, actually these are the type of people that, maybe we can label. The right-hand side, maybe we can label this way. Like that's sort of like our job. So for example, left-hand side, when you look at it, though, like, well, maybe like sometimes it's not just like, this is where like your subjective matter knowledge help, but also you can use the data in certain ways to help us to kind of guide, you to look at certain things in there as well. But anyway, so here the left-hand side getting accused of, like I don't even have to say that, and the right-hand side is not. So like all of a sudden, like you start kind of like getting like useful insights from the data. And obviously, like what we want to do is we want to extend this data and see like we can find even more like similar patterns there or now. So to do this, there are many algorithms to do this actually, and then one of the algorithms, and then most popular one is called K-means, and that's the topic that we're going to take a look at. And three things about K-means clustering. First one is to specify the number of clusters. You actually have to set the number of clusters. It's not like the algorithms will tell you how many clusters it will need to create. So, and then also only based on the numeric variables. So like if you have the categorical variables, then you can't use it unless you do, use some kind of technique or like one-hot encoding or something to make that as a numeric variables. But that's not really a topic here. But if you're interested, let me know after this class, after this course. And then the third one is can be affected by noise and outliers. So the data, for example, like you have like different variables, and the different variables don't share the same unit. One is, for example, dollars, and one is like a weight pound or something. Then you need to take care to make sure those variables are presented in the same scale. So I'm going to cover that later. Okay, so enough talking, and then so let's get into the example here. So what we're going to use US baby data. This data is about each baby was, like how many, what is the weight pound for the baby, or what are the mother and father age of the baby, or like if mother was smoking cigarette while she was pregnant, and the baby is male or female. So that type of data. Okay, and then if you look at the table view, it looks kind of like this. So like each row represent each baby. Okay, and then what we want to do is cluster the US states. Instead of like clustering the US babies into the certain groups, we want to do here is that we want to cluster US states into a few groups based on their similarity. And we're going to use father age and mother age variables to start with. This is sort of like kind of a starting point for demonstration. And usually like you're going to use a lot of variables as well, many variables as well. But let's start with just 2 variables because it's more intuitive to understand what it is. Okay, and also though, like I'm talking about here, like a clustering in US states, but that doesn't mean like we can't cluster the US baby. That's totally fine. I'm just kind of using this as an example. Okay, so the data preparation, and then when I talk about like algorithms, it's like if we just talk about algorithms, that's cool for one thing. But in the real world, you always have to prepare the data in a certain way. So here as well, like we're gonna need to prepare the data. So that to feed the data into the k-means clustering, there's one thing we need to know, which is, I mean, there are many things, but one of the things you need to know is that the thing you want to cluster, in this case, US state, needs to be presented as its own unique row. So one row means one state, right? So currently, because one row is a one baby, so like let's say like Georgia of the state, we have maybe a bunch of rows, like let's say like 100 or 200 rows or something. But before we give this data to the clustering algorithm, we want to make the data to be like this. So like each row, for example, first one is like Arkansas. Sorry, I'm not 100% sure what's the AK is. Arkansas, Alaska, one of them. But anyway, so the one of the row is the state. So like we have to actually aggregate or summarize the data and to make this the data to be this format. So that's something that I'm going to do, and then finally, like we can run the k-means algorithm. So let's do that. Okay, so here, the data that I was talking about, the US baby data, same data here. I'm gonna hide the left-hand side. And so I already imported this data, and then I'm gonna share this data after this session. So you can, if you like, you can download from the link, and then you can take a look at it. You can just put your hands on this data as well. Anyway, so here, and then let's go to the table view, and then here, exactly the same thing that we saw in the slides, right? So what we want to do is we want to summarize by the state, and then we're going to get like mother age, average of mother age, and also let's get the average of the father age as well. So to do, first, like select the state column header, and then like, select the group by. And then now like we got like 51 groups. I think this is like 50 states plus Washington, D.C. And then, so each state has its own color here now. But now, and then the right-hand side, when you look at it, there's a group by step. And what we want to do from here is to get the average of these 2 variables. So start with mother age and summarize, and then mean average, and select that from the column header menu. And I'm going to keep that like a column name as is, and then click run. Now what we got here is that we have like 51 rows. So each row is now for each state. And then we want to get the father, a mean of father age. So I'm going to click on this plus button, and then select the father age for the column, and then change the aggregated function to mean average. And let's name that column to be father age mean. And we get 2 columns here. So let's take a look at this data at this point, what that data looks like. So go to the chart, and then select the scatter. And then like x-axis and y-axis, I'm going to assign those like average of ages. So the data looks kind of like this. And then to make it easier to understand what each dot means is I'm going to assign the state and then show on plot. Okay, so mother age is the x-axis and father age mean. So this is like an average of father age and mother age, right? And then sort of like kind of correlated between these two variables. But you can see, for example, DC is Washington, DC. This DC is actually not really unless you're Americans, you don't know what this, for example, WI is. So I'm going to just quickly convert this to something easier to understand. So there is here, under the replace field convert data, there is convert US state. I'm going to select this and then select the output types as name, and then click run button. And then now like this short code, 2 letters converted to the state name. So AK actually the Alaska. So I was half right, half wrong. Nonetheless, and when I go back to chart and then try to select the select code, but it's not there because right hand side, what I did was I actually added a new step to do the conversion of the state name. But the chart was pinned to the summarize step. So I want to actually move this pin step to the last step. And then like, I should be seeing the state code, the new column that we created. And then now like, we can see the state name here. So, and then like, I'm going to just kind of squeeze a little bit here by using the, at the bottom, kind of arrow things. By using the mouse. So the District of Columbia, Massachusetts, Connecticut, New Jersey, New York. So these are the states that average of mother and father age tend to be older when they have baby. And then at the opposite is here. These are the states that like mother and father age tend to be younger when they have babies. Okay. And then so and then what can I can do is I gotta make sure everybody's mute. Okay, and then what I can do here is let's take a look at with a map, and then so we can see even better. So like I'm gonna select the map area, then U.S. state, and then change that to state code, and then here, for example, like a mother age. So this is like what I'm doing is trying to see like focus on the mother age, average of mother age. This actually average sum or mean doesn't make difference because there's no aggregation happening here. But anyways, nonetheless, you can see it. So these are the states that like tend to have like older and younger age of the mothers. Okay, so we got kind of brief ideas, but what we want to do though is to basically we want to cluster the states into, let's say, 3 groups, right? And then like intuitively thinking, okay, based on the mother and the father age, like so both of them are older, so that's called like a cluster 1, maybe medium is cluster 2, and then lower, like younger, or the cluster 3. So that's exactly what we are trying to do. And what that is let's take a look at how the k-mean clustering works. So, so we have the data. So this example is slightly different, but nonetheless, we have like X and Y, or like 2 variables, right? And then we want to group this data based on the values. Okay. And then, so eventually, this is what we want to get. And then, so what we want to do is basically, I'm going to talk about like how the algorithm is doing internally. Okay. And then you're not going to do this manually, so don't worry about that. But anyway, so the algorithm is basically set the center of clusters randomly. So like it's just kind of like a dodge game or something. And then what's going to happen though is that to each dot, find basically like we're going to categorize these, not we, but the algorithm categorize, group the dots based on the distance. So all the dots finds like, hey, you know what, like I'm closer to the red, I'm closer to the red star, or like the green star. We basically find, assign which star each dot belongs to. And then move after that point, then the algorithms move the original center locations to the center of the dots, or like to the average of its move each cluster, center of the cluster to the average of its members to make sure that distance sort of like So like, think of it as like it becomes the real center in each color. So in this case, the red moves a lot, and then green as well. They want to be the center of surrounding dots, right? So when you do though, what's going to happen is that it's now, for example, focus on kind of like a red, very closest to the blue. So I'm going to just use the mouse right here. This dot, just focus on this one. And then now that red, is it still closer to the red, or still now it's closer to the blue star? Because the blue star moved, right? So therefore, maybe that red dot that I was talking about, now it might be closer to the blue. So that happens, the reshuffle happens because the center moves. Then basically, like we assign all the dots to the closest to the stars. And when you change the assignments, then those stars or the centers want to move to the center, real center again, based on the reshuffle, reassigned data. And when the center moves, or the star in this case move, then those dead dots again start finding what are the closest stars. So the assignment might change again. And then you basically, as you notice, though, this step 2, step 3, like keeps repeating until all the centers don't move anymore. Basically, kind of like stay there because there's no point of like keep shuffling when you don't move. And then that becomes the final cluster. So that's what the algorithm actually really doing. So let's say in Exploratory, we can run the k-mean clustering in 2 ways. One is a command step, another one is analytics view. We're going to start looking from the command step first, then later we're going to cover the analytics view. Okay, so let's do that. But back to the Exploratory. So again, same thing. We want to run a k-mean clustering algorithm, and think about it again. It's throw the three points, and then do the reshuffle that I was talking about. And eventually, we are hoping there will be 3 groups based on these positions. Okay. So go back to the table view, and what we want to do is we want to use these 2 variables, so the mother age and the father age mean. And we are assuming each row is each state, right? So we have 50 rows. Then from here, from the column header menu and under the analytics, and then select the cluster with k-means, and then select the columns. And in this case, we're going to run it. But one thing notice though is that the number of cluster default is 3. And then that's one thing is that like being often asked is that like how many clusters do I'm supposed to set. I'm going to talk about that a little later. So let's just keep as default as 3 for now, and then we can just shuffle this later. Anyway, so let's click on run button. Then now immediately the response comes back, and each state has its own cluster numbers. So between 1 to 3, between 1 and 3. Now, what just happened, let's take a look at in the chart. If we assign the cluster, again, we don't see that cluster column. That's because this chart is still pinned to the previous mutate step. So we're going to move that pin to the last step. If we don't want to keep moving this pin step, you can simply just unpin it. Then that means whatever the step you're selecting, the chart is always looking at that step. So that's sometimes easier, but sometimes it actually gives you surprise because like all the side of the column doesn't exist when you move with different steps. For example, I'm going to assign a cluster to the color by, and then when I move to the different step, and then the cluster column is not there, then in that case, this column get deselected. So if you don't want to have something like that, like make sure you pin it. Anyway, so the whole point here is that like now, like you see this is a different color. So the cluster 1 tend to be around here, cluster 2, and the cluster 3 are the younger mother and father, right? So to make it even like easier, so like from the color by, and then you can even show circle around the color as well. And this is just a kind of like a guidance, so like it's not necessary, but I just wanted to give you the idea of that. Okay, so just imagine, we talk about like how the k-mean algorithm works internally, and then this is basically, that's exactly what happened. And we get that result here. Okay, so however, it doesn't have to have only two variables. This is super easy sample, right? Like, because we had a father age and mother age, and we get the result in a way like we sort of like expected in a kind of intuitive way. Like, it's almost like, hey, you know what? Like, I can actually do this by myself, right? But usually things are not this simple because you might want to use more variables. In this case, we are using father age and mother age. But what if like we use like, let's say like you know, when mother was mother smoking when she was pregnant, right? So that if we want to bring that kind of information, all of a sudden that becomes sort of like a 3D. And then if we bring, let's say, like weight pound, if the baby is heavy or not heavy, light, that kind of information, all of a sudden we're talking about the 4 dimensions. And then that goes on and on. It can be like 8 dimension, 9 dimension. All of a sudden, like our eyes can't keep up with those type of things, right? So let's add another variable, and it does, you know, things more interesting. So here, what we want to do is let's go back to summarize step. We have only like a father age and mother age, but when you go back to the group by, we used to have a lot of columns. Like what happened? Well, like when you do the summarize, you get only the ones that you explicitly specify how you want to aggregate. In this case, by using mean function. So we have to actually specify like how, you know, which column we want to bring and how we want to bring. In this case, what we want to do is let's bring this like a cigarette use column here, true or false. And based on this, like how many of the mothers were smoking or not smoking. So like let's get that sort of a ratio, right? And that, like you go to the summarize step again, and click on this plus button, and then select that cigarette use. This is a logical data type, true or false. If not, like you can actually convert to the true or false as well. And then like aggregate function, like I want to select that not number of true, because we know actually that I know that there are a lot of people in California. So like number of true doesn't really, it's not really fair. So let's see like a ratio of true. So like let's say 20% of the mothers smoking versus the 80% of the mothers smoking states, right? And here, let's say like cigarette use ratio, and then we get something like this. And then there are some NA, because California, for example, states like California doesn't provide this information, therefore it's NA. And the one thing though, like a K-mean clustering can't do anything for the NA, right? So there's no, so we have to take care of this NA. There are a bunch of different ways to take care of this type of the NA values, but here for the demo sake, like I'm gonna just remove this stuff for now. So let's remove, and then it's not NA. So now like we got how many states here? 44 rows. So let's start from here. Then what's going to happen though, like if I go to, what is this? Oh yeah. When I go to the last step, run k-means, and it looks like the k-mean algorithm is run. However, like when I click on the k-mean algorithm dialog, the columns are only 2, mother age, father age. So I have to actually add another one, like cigarette use ratio. Then click on run button. And then like you get like a cluster ID. So has this, so do we have the different result now? That's the question, because we added another variable, right? And when you go to the chart, and doesn't look like much difference, right? So it's sort of like a right-hand side top is a blue, like a cluster 1. Left-hand side bottom is a cluster 3. And so let's examine what's going on. So here's a mother age and father age. Looks like based on these 2 variables, there's a kind of clean sort of like separation. But if I change that to, let's say, cigarette use ratio, this is what we get. But this cluster 1, 2, 3 seems to be like, it is almost like just using mother age mean. So like, for example, like if less than 26 years old, then you are in a cluster 3. If you are older than 28, then you are in cluster 1. And the cigarette use ratio is sort of like maybe blue is kind of lower, and then green is higher. Let's take a look at the father age as well. Father age, that same thing. The father age is now the x-axis. And then so the green and the orange are pretty, it's kind of like a similar, like you can't really rely on the cigarette use ratio to identify, separate these 2 clusters, or even like 3 clusters, right? For example, Maryland. I mean, like you can't really use a cigarette use ratio. So what's happening here is that like, it seems to be what's actually happening is it is using only father age and mother age to do this like a kind of grouping or clustering. And it's not really using what you call it, like a cigarette use ratio. Well, what's happening though is, okay, if you go to the bar chart and let's see like by the state, and then let's assign like a mother age and a father age, and then the cigarette use ratio here. And I'm gonna use like a grouped chart. And then this is some, but because each row has its own state, so it doesn't matter. It's basically it's the same thing. That here is average or whatever. The one thing though I want you to notice here is that all we see is like a father age and mother age, but we are not really seeing the cigarette use ratio. That's because that's a green color, and that's actually around here, and then that's where we see. And then that means basically the difference between the states or among the states for the cigarette use ratio are not much compared to the difference between this among the states for example, father age, right? The father age difference is like actually, for example, it can be like a 3 years difference or like 5 years difference among the states. But the cigarette use ratio, the difference is we're talking about is like it's between the 0 and 1, and it probably the difference is like 0.1 or sometimes like 0.05 or something like that. So therefore, the K-mean algorithm doesn't think that kind of difference are useful. Therefore, like, they tend to focus on the bigger number of the difference among the states. So what we actually needed to do is we don't care about the row number, row difference, right? We care about the difference among the states, the focus on the difference. How we can do that is that's where like it helps like to think about like sort of like average and the standard deviation or the variance of the data. To do, we can actually normalize the data or scale the data. That means based on you can rescale all the numbers, then make the average as 0. And then like based on how variant each variable is, then we basically apply the standard deviation, and then basically divide by the standard deviation, and then we come up with a kind of like normalized numbers, right? So, or standardized number. So to do, let's go back to table view, and then let's select these 3 variables. Actually, we want to do before running the K-mean, right? So before, we want to actually give this normalized numbers to the K-mean algorithm. So let's go back to the mutate one step before, then select these 3 variables, and then let's normalize it. So like we want to select work with numeric function, and there's one function called normalize. And then once we run it, and then it becomes something like this, right? And then now, basically, if you see the numbers closer to 0, that means that state is actually very close to the average values. When you see bigger numbers, that means that state is very far from the average, and then and the order from the average compared to the average. And then like, if you see like a minus, that means less than the average, right? And what that means, well, like when I go to the chart, and then you get the result like this. In this case, this chart happened to be already pinned to the last step, and I added the step in the before. So you see here is like now you can see, like orange, blue, and also green in the same scale because 0 is the average. And then it's just a matter of like, for example, this day, I don't know, this like a WB with, wait a second, let's assign like a state name here. So this is West Virginia, for example, and it has this green super high. That means the ratio of mothers smoking cigarettes is higher, much higher than compared to other states, right? And then like you can see, for example, this state, this is like District of Columbia. The father and the mother tend to be much older compared to other states. And then also the cigarette ratio is much smaller. Okay. So based on this information, then how can we cluster the data? I think this is more fair because then like we can consider all these variables. So if we it's the select let's go to by the way, so like a step is now like run k-mean clusters. So like the cluster ID reach assign, and then go back to the scatter chart. Now like you see something like this. Now here, that in order to separate orange cluster and then the green cluster, only father age is not useful. So it's sort of like mother age, certain part useful, but seems like they are sort of like overlapping area. And that is where cigarette use ratio should be helping. So like in order to separate like orange and green, cigarette use ratio is more helpful. And then, for example, here is like, let's take a look at it compared to the mother age. Again, the mother age alone helps to separate these three clusters, but also like we need cigarette use ratio to explain this the difference between, for example, orange and green, or like orange and the blue. And then actually, though, like you can actually assign the z-axis, for example, what are the here for the age, to get that 3D chart view, and then that might help you to what's going on here. So in the 3D view, though, like you see like the kind of a grouping in a way kind of makes sense. That's because we use the three variables are used to group these states. Okay. So having said that, like when you go back to the chart, this is the map chart. And again, like I want to actually move this pin step to the last step. And then, so this result we are looking at here right now is like a mother age. So we want to change that to cluster ID. Okay. And then the result we are looking at here is that based on those three variables, and then a cluster 1 is and cluster 2 and cluster 3, those three color coded. Okay, so now, we have normalized number numeric variables, and then like we fed that data to the k-means clustering, and it seems like this clustering is fair. But next question though is like, so what's the cluster 1 really is, and what is the cluster 3 really is? Like a cluster 1 means like mother, father order, and then cigarette use ratio is lower. And then what is the cluster 2? What is the cluster 3? And then with three variables like that, if we have only three variables, still kind of like you can juggle around a scatter chart and then bar chart, and you can somehow like see like that type of patterns by using your eyes, right? But when you start having more variables, it's becoming harder to see like what is cluster 1 really means. So there's a way to transform this data and visualize it, but it's kind of cumbersome. So what we did is actually though, like, under the analytics, we added a k-mean clustering. Therefore, like you can quickly basically do the same thing, and then that way, like you can actually get like a preceded charts that will help you to understand the characteristic of each cluster. So let's do that. So select the k-mean clustering. And then you don't have to select this last step. It can be, for example, here, even like we don't even have to scale. The cool thing about the analytics view is like that scaling or like normalizing is done automatically. So you don't even have to do that. So let's say like we are just somewhere around here. I'm going to move that step here. And then, so we don't have, the data doesn't have a cluster column. And then the numbers are still original values, right? And then I go to the analytics view and select the k-mean clustering. And then here, select the column. So we want to use these three variables to create the clusters. And then we can run. And the subject columns, well, like we're interested in this as state, right? So like state name. And then I run. This, you don't have to select this. Then whatever the row becomes your subject of the cluster. But here now we see kind of like three groups. And what happened here though is that like it says PC1 at the x-axis and then PC2 at y-axis. It's not like mother age, father age, or any particular variable. And these two, this is called primary component, is behind the scene using primary component analysis algorithm to create artificial dimensions to express the original information as much as possible. And another way to say is like try to reduce the dimensionality of the original variables. In this case, we have 3 variables, right? Like mother age, father age, and then cigarette use ratio. But this is sort of like using the only 2 dimensions or 2 measures to express the information that used to be represented by the 3 variables. Okay, and then by looking at here though, is that like this father age and mother age, so these 2 original variables are expressed as this great straight line from the center, and then the cigarette use ratio is also here. So that means whenever, whatever the dot, each dot by the way is a subject here, which is a state code, state name. So let's say like New Jersey, and this Massachusetts, and then DC, Washington DC, and those are like closer to this like father age and mother age. That means the values of these 2 variables are higher for these dots. Okay, and then if you see the opposite end of that, it means that like lower the values of these 2 variables are lower for these dots. And then this orange is the kind of between the blue and the green. But what's happening is the orange, intuitively speaking, is kind of closer to the cigarette use ratio. So it seems like these orange are not like kind of higher values for these 2 variables, but kind of like between green and the blue. But somehow it's more kind of like towards to the cigarette use ratio. So probably we can assume, we can start guessing this cluster 2, probably mothers are, the ratio of the mother smoking cigarette is higher for these states. Okay. And then also another thing we can say is like father age and mother age, these 2 variables are pointing almost like the same direction. That means these are highly correlated. But the cigarette use ratio, on the other hand, is not really pointing in the same direction. That means it's not really correlated along these ages, okay, with age variables. And also now, like we can go to explore some other chart types to understand like what are these variables clusters are. So cluster 1, the mother father age tend to be higher. So this is a box plot. So like the center line is the mean, and then the box is 50% of the data around in the center area. And then like at the top and at the bottom is the mean and max, max and mean. So that means that this cluster 1, the distribution or variance of the mother and the father age tend to higher. And the cigarette use ratio is not super, but it tend to be lower. And then this cluster 2 are the ones actually higher. This is actually the similar information as what we are looking at. The cluster 2 is the orange color here, right? So like when you go to the box plot, in this case, color is slightly different, so it might be confusing. But here, cluster 2 here, the cigarette use ratio is higher, and the mother-father is lower. And also cluster 3 in mother-father is the lowest in a way in this all of the data. And then but cigarette use ratios tend to be lower compared to the cluster 2. Okay. So we can start labeling, based on this finding. But let's take a look at the other chart as well. So this stack bar is sort of like help you find like which state it belongs to which cluster. But also, if you have other information, for example, let's say like this is another example. Let's say like this like a Republican governor state or Democratic governor state or something like that, and then we can see like which party belong to which cluster, that kind of stuff as well. So it can be useful. In this case, not so much. And then error bars also, this is more to do with average. So like what is that, like further, each cluster's average. So for example, cluster 1 average age, father age is what's here, 31. But average is, when you get the average, it can be like skewed by the extreme values. So therefore, like we have like this error bar showing sort of like a standard error, standard deviation in this case as well. You can change this like to be, let's say, confidence interval or some other measures by using this property as well. Okay, And then like, you can see the line chart. This is like each line represent each state. So for example, the DC, the mother age mean is here. In this case, it's actually standardized values. So it's not like a 2 years old, but standardized values. And 0 is average. So like the DC is higher for the mother age. Father age is also, it's actually the oldest in this group. And then the cigarette use ratio is super small. Okay, so you get kind of like high level understanding of each cluster, or like, you know, what are each subject is, you know, belong to, that type of information. Okay, so so we get so in this case we have only 3 variables, but nonetheless it's still useful to cluster this way. But in reality, like, you start adding more variables. So now, like, one thing though, so like basically in the last 5-10 minutes, what I try to do is to answer the question of the what is the characteristics of each cluster, right? What cluster 1 mean, like, compared to cluster 2, cluster 3? What are the difference? What are the similarity within each cluster, or what are the difference between the clusters? But now, like, one question I haven't answered yet is that, like, so in this case we have 3 clusters. Is a 3 is optimal, or like, is that like a 4? Is that like a 5? Or is it a 10 or whatever? What are the numbers, the optimal numbers, right? So the best number is, of course, is that best optimal number is that like a cluster 51, because we have like 51 states, right? In this case, I filter the data, so like we have only 44 rows. So like, let's say like if we create the cluster with 44, then it's actually perfect. But then there's no more point of even doing that, right? So what the goal here is to find similarity among the states based on these variables. So like we have to sort of like figure out like what are the kind of optimal. And to do is, one way to do is something called elbow method, and I'm going to show you here. Is that like if you open the property at the bottom, it says elbow methods, and you can actually turn this on selecting by selecting true. And then like maximum number of clusters to try is like 10. That means it is going to automatically create a bunch of clustering model. Like one is for like cluster 1, another one is cluster 2, another one is cluster 3, and so on. And they compare the basically the distance between the center, center and each dot. So like click apply. And then basically this number is the total within cluster sum of squares. What at the high level though, in more intuitive understanding of this number is that average numbers of the distance between the center. You remember the center, like stars in the when I was talking about the slides, and then each dot. And then obviously the more clusters, the distance becomes smaller. When you have one cluster, that that distance is the biggest, right? That's sort of like intuitively making sense. But then so that distance start going down. But the question is like if we know that like it eventually goes to close to 0, right? But then the challenge here is that like if we do, then like we can't even find a similarity. So when you look at this line and then compare that to your arm, and then try to find the elbow. So in this case, probably around here, that means all of a sudden when you adding another cluster, like increasing the number of the cluster from 1 to 2, obviously the distance got much smaller. And then when you add to the 3, it got smaller a little bit, and the cluster 4, and even smaller. But after that, it's sort of like it keeps decreasing. But the ratio, the sort of like a ratio of the decrease kind of like a stop around here 4. So probably like after that point, like you can keep reducing the distance, but it's sort of like what is really the point? There's not much make the difference, right? So let's say in that case, we can say like, okay, that 4 is probably the optimal number of the clusters. Then you can actually go back to the property, and you can actually type the 4. And then the elbow method first, because what we want now is to get the original k-mean clustering. So click apply, and then like I change the number of the clusters to 4. So like therefore like I'm seeing 1, 2, 3, 4. And then the 1 is still basically father age, mother age higher, and then the cigarette use ratio is also like opposite side. But now here used to be we had a cluster 2, or like basically something between this green and blue. But now like we have this like red color, which is kind of between, but also it's more have the characteristic of like cigarette use ratio. And then there's this one, orange color, which is just between, sort of like mother age, father age. It's not like young or old, but it's in terms of the cigarette use ratio is much lower. So this or red color are the ones sort of like mother age, father age are younger, and then cigarette use ratio is higher. And the green is mother age, father age younger, but cigarette use ratio is lower. And then like we can actually go to the box plot and see that. So so for example, here the cluster 4 is the one cigarette use ratio is higher, and then mother age, father age are kind of like lower. And by this way, we, you know, probably like it depends the context, but okay, so cluster 4 is this type of characteristic, and cluster 4 is this type of characteristic. So if that's more useful, then like you might you want to stick with this number of the cluster as a 4 or something. And then this kind of simple data, that result doesn't make much difference between the command on the analytics. So like if I go to the command line mode and then click on the run k-mean clustering, and I'm going to open this app and then type 4 number of clusters. So what I'm doing here is more like a command step mode. And then you get like 1, 2, 3, 4. And I like doing this way. Then like I can have more flexibility of in terms of how I can visualize the data. So I can, for example, use the map. When under the analytics, what you can do is kind of limited because you can't add a new type of chart. So, but it helps you to explore the the characteristic of the clusters, like optimal number of the clusters, and so on. Once you get that idea, then you might want to come back to the step way of doing things. Then you have the full capability of the visualize, or even like based on this data, you can start doing another type of analysis, or you can use this data as a part of your data wrangling type of task as well. But nonetheless, here, like now, like you see step 4, cluster 4, that is the cigarette use ratio is higher, and then mother, father tend to be younger. And then cluster 2, cigarette use ratio is lower, but mother, father still younger states, and so on. Okay, so that is the k-mean clustering introductions, and also how you can use it in Exploratory. Let me just go back to the slides, and here. And in this slide, I'm gonna actually publish and then put that link on our online seminar page as well. So if you are interested in taking a look at again, or you wanna actually try by yourself, then you can take a look at it as well. Okay, so and then like the last, we're gonna keep doing this like online seminar. However, now we are coming into like end of the year, so we're gonna skip the next week and the next another 2 weeks, but we're gonna resume from January 8th. And then I'm gonna switch gear a little bit. We've been talking about like analytics or machine learning or side of things, but I want to cover introduce data wrangling side of things as well. So we're gonna focus on the date and time data, and then how you can do more time series analysis based on that. And also we are planning for other topics as well. But if you have some other topics you like us to cover, please let us know. And then you can contact me at Exploratory.io, or you can follow me, August at Twitter. And then here are the links, our data science training or online seminar, and so on. Okay, so with that, I'm going to close off, and then I want to open up a Q&A. If you have any questions, please ask. Chat window is also available. So either way, you're mute, so you can unmute and speak up, or write something in the chat window. Okay, so I'm gonna just here we go. Ooh. Sometimes I don't know. Okay.